Now we come to physics, liquids 3, and in this section we will cover Archimedes' principle. Archimedes was a Greek and is famous for having discovered a principle that governs all liquids, the Archimedes principle. Let us proceed now to understand his principle. It is a common observation that when you push a body into a bucket full of water, you experience a force in the opposite upward direction. This is very common. This means that the water exerts a force on you when you immerse a body in water. This water could be in the liquid also. The same thing would happen. If you just put the body in water, it either floats or sinks. Now, why does a body thrust into water or any liquid experience an upward resistant force? Why do some bodies float and some bodies sink? These questions are answered by the Archimedes principle. When you put a body in water, that body displaces water. The level of the water rises. How much water is displaced? This is a very important question. How much of water is displaced? Obviously, the volume that the body has occupied in the water, that much of volume of water is displaced. Now, the displaced amount of water tries to get back into its final position, and this gives an upward force to the body. This is called the buoyant force, as it is trying to keep the body up. Obviously, this buoyant force is equal to the weight of the water displaced. So the weight of the water which has been displaced tries to get back to its position with a buoyant force. Both of them are equal. The buoyant force is equal to the weight of water displaced. This is the Archimedes principle. Now, when does a body sink? When the weight of the body is greater than the upward force, which is nothing but the weight of water displaced, the body obviously sinks. When the weight of the body is less than the upward force, the body obviously floats. It's as simple as that. So clearly two things are important here. The weight of the body itself, the amount of water or liquid the body displaces. So there is 1 and 2. If 2 is greater than 1, the body floats. When 2 is less than 1, the body sinks. A cork floats on water because its weight is less than the amount of water displaced, which gives an upward thrust. An iron nail sinks in water because its weight is more than the water it displaces. That is, the upward thrust given to the nail is greater than the weight of the nail. But what about an iron ship? Why does an iron ship float and not sink in water? The ship is heavy, but it is big in terms of volume also. That's a very interesting point. The ship might be heavy overall, but its volume is also very high. When it enters water, the amount and hence weight of water it displaces is huge, and the upward thrust is huge. The upward thrust on the ship is actually more than the weight of the ship. Thus, the ship floats. Thus, we see both the factors acting always when we consider floating or sinking. Weight of the displaced water that determines the upward thrust on the body. Weight of the body itself. If 1 is greater than 2, body floats. If 1 is less than 2, body sinks. All bodies, whether they are floating or not, into water experiences thrust, upward thrust. This is equivalent to weight loss, isn't it? Suppose you are putting a body into, let's say, a glass of water, and the body is experiencing an upward thrust. Definitely, it's equal to weight loss. The weight acting downward is contracted by the buoyant force upwards. So, apparent weight loss, actually there's no real weight loss, but you feel the weight loss, is equal to weight of the body minus upward thrust, obviously. Thus, we clearly see how and why bodies behave the way they do when immersed in liquids. So that completes the Archimedes principle. I think you got it very clearly. It's a very simple principle if you understand how the Archimedes principle works. So that completes the whole chapter of liquids. This was liquids 3. So we did liquids 1, 2 and 3, and that gives us a deep, fundamental idea into how liquids work. I hope you enjoyed the show. Thank you.